Sorry, if you have headphones in, that's probably really loud. Okay.
Art.
Yeah.
Reed said she's going to be back. She had to restart her device.
Okay, that's fine. All right, so section 5.6, part 2. So this is the same thing that we've been doing. We're still graphing inequalities, but the only difference here is that whenever you're graphing these, you're graphing just a single variable. So you're not going to have a slope in your line. It's either going to be a vertical line or a horizontal line. So instead of doing these like on a number line that we did, you can graph these on a coordinate plane and still shade all of the right answers, okay? So you have 3x plus 5 is less than 14. So solve this just like a regular inequality. You want to get x by itself, okay, which means we're going to subtract 5 from both sides. That's going to give me 3x is less than 9, okay? And then I'm going to get x by itself by dividing by 3, okay? So x is less than 3. Now, you have to remember how to graph a line that's just x or just y. Anytime you have just x, that's a vertical line going through that number on the x-axis. Okay, so I'm going to go over to 3 on the x-axis, and I'm going to put a point there. And I know I'm going to be drawing a vertical line. The thing is, you also have to pay attention to this right here. Okay, what kind of vertical line you're supposed to draw. If it's less than, that is a dashed line. Okay, so we're going to do dashed line on here. And now we can do the test point. Okay, now for these single variable, okay, we can still do the test point. We can test 0, 0. But now you only have one variable. So if you have x is less than 0, or sorry, x is less than 3, you're only plugging in the x value, 0, and then there's nothing to plug in for y. So you only are plugging in 1 point. So 0, 0 is on this side, the left side of the line. Okay, 0 is less than 3. That's a true statement. Okay, so I'm going to shade where 0, 0 is, where it's true, okay, which is all of this over here. Okay, now you can also think of this on the single variable ones like we did on the number line. Whenever you would graph this on a number line and you would put a point at 3, it would have been an open circle and you would have drawn your arrow to the left. Okay, on here, we drew our line through 3 and then we shaded to the left. So if you're going to shade to the left, that's kind of like whenever you were drawing your arrow to the left, if that makes sense. Okay, so that helps you a little bit on that, but you can still use a test point like we've been doing and keep it the same. Okay, keep the same process there. Okay, any questions on that one? Yes, that's correct. Does that make sense? Okay, any other questions about that? Okay, so let's look at the second one. So we're still, again, trying to get the variable by itself. So 4x minus 3 is greater than or equal to 17. Okay, so I'm going to do plus 3 on both sides. So I'm going to get 4x. This will cancel, greater than or equal to 20. Okay, if I'm trying to get x by itself, I'll divide by 4. So now x is greater than or equal to 5. Okay, so I'm going to go to 5 on my x-axis. Okay, look at my inequality. It has that equal to symbol on there, so that means that it's going to be a solid line. Okay, and now x is greater than 5. So if you were drawing this on a number line, okay, and you would have put your close point at 5 right here, you would have drawn your arrow going to the right. Okay, you can do that same thing here, and you can go ahead and shade to the right. Okay, just like you drew your arrow to the right, you can shade to the right of the line. Okay, if you still want to pick a test point like we did in the last part, okay, I would have 0 is greater than or equal to 5. Okay, that is not true. That's false. So if 0, 0 is over here on the left, everything on the left side of the line is also false. Okay, all of this over here is false. So we would shade to the right. Okay, so either way, you still end up with the same set of shading. Okay. Any questions about that? Okay. Now, if we have a y variable, you have to remember that y makes a horizontal line. Okay, so our line is going to be horizontal in this case. negative 2y plus 6 is greater than 12. Okay, I'm going to have minus 6 on both sides. Okay, negative 2y, this cancels, is greater than 6. Now, you also have to remember the properties of inequalities, which says if I divide by negative 2, that is also going to change the direction of my inequality. So that's going to cancel, and y is now going to be less than negative 3. If you forget to change the inequality, you're going to shade the wrong side of the graph. Okay, so y is less than negative 3. Okay, on the y-axis, I'm going to go to negative 3. This is going to be a horizontal line, and I'm always going to double check and see what kind of inequality I have. Okay, this is going to be a dashed line going through negative 3, just like this. Okay. Now, this one is a little bit different because we don't necessarily have like a left or a right side. It's a top and a bottom. Okay, so if you test 0, 0, like we did before, 0 is going to be less than negative 3. Okay, 0 is not less than negative 3. 0 is bigger, so this is a false statement. Okay, 0, 0 is up here. Okay, so we want to shade where it's true, which is going to be all of this down here. Okay, now another way that you can think about this is if y is less than, if I'm looking at the y-axis and I'm looking at negative 3, all of the numbers that are down here, negative 4, negative 5, negative 6, negative 7, and so on, all of those numbers are the y values that are less than negative 3. Okay, all of these numbers up here, negative 2, negative 1, 0, and all of these positives, those are all greater than negative 3. So I want to shade where the answers are, okay, or where are the y's less than negative 3, and that's all of these. Okay, so you can still pick a test point and do what we've been doing, okay, or you can also think a different way as far as where are the y values or where are the x values that satisfy this equation. Okay. Any questions about this one? Okay. So solve and graph here. 4y minus 1 is greater than or equal to 3. Okay, so we're going to do plus 1 on both sides because we're trying to get y by itself. 4y is greater than or equal to 4. Okay, so if 4y is greater than or equal to 4, we're going to divide by 4 on both sides. Okay, y is greater than or equal to 1. Okay, again, a y line is going to be horizontal, so I'm going to go to 1 on the y-axis. It's going to be a horizontal line, and I'm going to double check my inequality. I see that it has equal to, so that means that I'm drawing a solid line here. Okay, so y is greater than or equal to positive 1. Okay, and then I'm going to go where are the y's greater than 1. Okay, so the y's are bigger than 1 at 2, 3, 4, 5, and 6, or 0, negative 1, negative 2, negative 3. All the ones that are bigger are these up here. Okay, and again, if you want to use a test point, you can test 0, 0. Okay, so 0 is greater than or equal to 1. That is false. Okay, 0, 0 is down here. All of these answers down here are false. All these up here would be true. Okay. Any questions about that? Okay, so you're going to continue on the homework. Okay, it's on the page. It's on the same page, 320. Okay, number 7, 9, 25, 27, and 29 are all of these single variable problems. So if you want to continue doing it on the same piece of paper, you can just relabel, like draw a line or something and label it as part 2. Because there are 2 different parts of homework. So just make sure you have it clearly labeled that this is the second part of 5.6, okay, and then you only have 5 questions that you're going to be doing here, okay? So are there any questions as of this moment right now?